All right, we've got here security.org, and it's about insecurity engineering. Let's give him a big hand.
Thank you. It's good to be here again for year number 6. This is Matt Fiddler, Tobias Blusmanis, for you that don't know us. We're going to talk today about locks and insecurity and some real problems. In years past, we've talked about high security locks as opposed to conventional consumer level cylinders. So this year, we thought we'd take a broad cross-section of different kinds of locks, talk about them, design problems and what the issues are, and run 5 videotapes showing how easily they can be opened. And we'd like all you really to pay attention, because at the end, we'd like you to vote on the dumbest lock design ever. This is sort of like American Lock Idol. And so we really want to know that, and we want some feedback if we have time as to what y'all think about the insecurity engineering that's gone into a lot of these products. And I might also note 3 of the 5 are imports, 2 from China, 1 from Finland, and then 2 are made in America. So we'll proceed. So lock design, mechanical versus security engineering, and we want to draw that distinction. All of the engineers at lock companies around the world are pretty good at making things work mechanically, but most of them really don't understand the concept of security engineering and making things not only work properly, but making them secure. So again, at prior DEF CON presentations, we've really focused on mechanical locks, high security locks, and now we're into the electronic and electromechanical locking systems. So we've looked at vulnerabilities in all of these kinds of cylinders that have resulted from defective or deficient engineering, in our view. There's also, as we've talked about many years in the past, the standards. And y'all need to understand, and we're not going to dwell on them today, but Underwriters Laboratories and Builders Hardware Manufacturers Association is responsible for developing standards in America for security systems, locks, safes, ATMs. And so everything in this country and everywhere in the world, as you know, runs by standards. And so if the standards don't cover real-world attacks, then there's a real problem and there's a disconnect, and the consumers are ultimately at risk. And so basically, everybody understands how to open certain locks, but they don't understand why they can be opened. So insecurity engineering, it's an intersection of mechanical and security engineering. You have to have both, or you can't make a secure product. And the real problem in our view is there's a real false sense of security by consumers, by business, even by some government agencies that don't have a testing program. They don't understand that a lot of these locks really aren't designed properly and can be opened and circumvented either by covert entry, forced entry, or a violation of key control in seconds by very simple techniques. The other problem is there's a lot of misrepresentations, either knowingly or not, by a number of lock manufacturers with regard to the security of their products. And this is really a problem in the industry. A lot of them, frankly, use the standards as their cover to say, well, our locks meet the standards. The problem is the standards don't cover a lot of issues, or they're not interpreted to cover, especially, for example, bumping, which we'll talk about later as far as what the industry has done since this has been public for the last 5 years. They have made changes. And so this is what we're going to talk about today, and specific design failures in 5 different kinds of locks. Matt?
So we have the QuickSet Smart Key, which is right up here. And again, remember, you're going to vote on what is the... Hello? Can you hear me now? Much better. All right, so we got the QuickSet Smart Key, which is right up here. We have the Kaba InSync, which is...
The middle one.
Right here. Next to the big safe over here is the AMSEC ES 1014. The iLock. Toby, if you want to hold up the iLock.
Well, the iLock is very small, but there it is.
This is really, really, really a clever lock that we'll talk about. It's developed in Finland. There's no batteries. It's an electromechanical lock, but there's no batteries in the lock. There's no batteries in the key. And so the real important thing in that issue to remember is clever does not mean it's secure. And
Neither patents.
yeah, patents don't mean it's secure. Clever doesn't mean it's secure. Awards don't mean it's secure. As we've repeatedly shown at DEF CON and other venues, there's a real disconnect in engineering. And I should also note that Toby, to my right, is a 25-year working locksmith in Miami. We all work together on analyzing locks and high security systems for a number of clients. And so Toby's got unique field experience in both Venezuela and America in day-to-day servicing and lockouts and bypass.
So the last lock over here is the BioLock 333.
Oh,
and
yeah.
so each of them was examined for security exposures and vulnerabilities, and we'll review that coming up with the videos.
Yeah, the BioLock 333. That's one of our special pet projects. This is a fingerprint lock, and we'll talk about it. This is a brilliant design. So locks are the first line of defense. They're usually the first security barrier, often the only security layer, and usually locks are measured by standards whether they're secure or not. But what if the problem is that they're not rated? What if the bypass technique isn't covered by the standards? And how do you know that the locks you put on your residence, your business, your computer server room, how do you really know whether they're secure or not? And frankly, what does the term security mean? Now, we think that manufacturers have a special responsibility when they're making locks. They're not making toasters. They're making locks to protect you, your lives, your assets, and your family. And so they have a unique responsibility for competence. And a lot of the lock manufacturers have not adequately displayed that in our view. And the 5 locks that you're going to see videos on today clearly have not demonstrated the level of competence that I think everybody expects when they go out and buy a lock. And we're going to ask you if you would buy these locks after you see the video. So again, it's mechanical engineering to make them work, but it's security engineering to make them secure. The implied representations, and of course this gets into, I'm also a lawyer, so the issue with security is liability. And if something fails and somebody gets hurt, somebody's liable. So the lock manufacturers, all of them, are representing that we are the experts and we understand our products, we understand security, and they're making representations in their packaging and their web advertising, in their kiosks, that these locks are secure. AMSEC, which is a great company that makes this little electronic safe for the consumer, about $100, they're calling it a safe. And this is a very, very good company. They've been around a long time. They're very reputable. This is an import, as we'll point out. It's not secure. And so they're selling it as a safe rather than a box with a lock on it. And that's honestly what it really is. It's a box with a lock. So, and a lot of the manufacturers will tell you we meet or exceed the standards. Well, that's great until the standards don't cover what the problem is. And when we can open locks with wires, with shock, vibration, with bumping, with magnetism, with radio frequency energy, it's a real problem because most of it's not covered in the standards. Matt?
And paper clips, ballpoint pens, aluminum foil.
Let's not forget the ballpoint pens.
And a host of other bypass techniques.
Right. So expertise is required in lock design. Mechanical engineering, security engineering, minimum industry standards require a level of knowledge. And security engineering specifically requires an understanding of all these bypass techniques. And if you don't have that, you can't make a lock that's secure. So engineering failure is the results and consequences. Insecure products, often very easily bypassed, as we're going to show today. Use the standards to measure when they do not address the relevant issues. The products, all of these products look great. The problem is none of them are. They all really look secure, and especially the imports from the Orient They figured out how to make chrome 1 micron thick look really great until you take it home. And then it doesn't work so well. The problem is the consumers, you guys, you don't understand this a lot of times, and you believe what the manufacturers of their advertising represent. So cost and appearance versus quality and security. Do you get what you pay for? $2 locks are $2 locks. And quality costs money. Quality equals tolerance and materials. And some of the cylinders that we've dealt with, $2 to manufacture the cylinders that are being sold for $20, $30, $40. The problem is they're still a $2 lock. And that doesn't equal security. As we noted, clever designs, frankly, may reduce security, not increase it. There are lots of really neat locks out there, and a lot of them are indeed secure, but there are a lot of very clever locks that aren't secure at all. So, security grades versus security ratings. Matt, why don't you talk about this for a minute?
So we talked about security standards a couple years back in ANSI, BHMA, and UL 437, specifically with regards to the medical locks. The security grades, as we'll talk about with the QuickSet Smart Key, it's a grade 1 lock. So as you look at the packaging, you're in the store, you're in Home Depot or Lowe's, and you're about to purchase this lock, you're looking at the package that depicts a product that's grade 1 security. They present a pictorial that shows grade 1 security as the highest level of security you can buy in Lowe's or Home Depot. So that's the concern. That's the concern for you as a consumer.
So, and because grade 1 security, okay, if you call, for example, QuickSet, my favorite, and you ask them, what does grade 1 security mean? They say, well, it's the highest grade of security you can get. Yeah, but what does that mean? Well, it's the highest grade of security you can get. And so you can't cut through it, you can't drill. The only way to open these locks is to drill them off the door, break the door, or break the door frame. We've been told repeatedly that that's the only way to open these locks. Well,
we had to mention also specific on the QuickSet Smart Key that this design is peak resistant and bump resistant. So the manufacturer tell us that since you cannot pick open this lock and bump open this lock, the only way that this lock can be opened will be through